Let's start with the first question. Which of the following scenario may lead to an irrecoverable error in a database system? Right? So they have given the options as a transaction writes a data item after it is read by an uncommitted transaction. A transaction reads a data item after it is read by an uncommitted transaction. A transaction reads a data item after it is written by an uncommitted transaction. A transaction reads a data item after it is written by an uncommitted transaction. Which one is the correct one? Option D. Why option D? Why not other options? So here they have specifically mentioned it should be an irrecoverable. What is the meaning of recoverable? Right? So we have explained the terminologies of recoverable schedules as well as non-recoverable schedules, right? So non-recoverable schedule means what? Non-recoverable, which means that if some transaction Ti and some transaction Tj, if Tj is performing some kind of read operation which was written by some other transaction Ti, and while reading this operation by Tj, if it is going to be read which has an uncommitted transaction, then definitely it is going to be a non-recoverable. Why it is non-recoverable? Because if this operation is going to perform commit operation, if some failure occurs at this Ti, what is going to happen? We cannot able to get back to the old state. We cannot able to recover to the earlier state. That is why called as non-recoverable state, right? So here, so non-recoverable is equivalent to irrecoverable, right? So if I say the option B, a transaction reads a data item after it is read by an uncommitted transaction, right? So here if you try to clearly observe, read followed by read, is there any necessity to consider this option at all? No need. So this option is not the correct one. What about this operation? A transaction reads a data item after it is written by a committed transaction, right? Meaning that transaction T1 is there, transaction T2 is there. One transaction is reading a data item which is written by some other transaction, and the transaction is also going to be a committed one after it is written by a committed transaction, right? Is there any particular problem? No. This particular option also there is no problem. What about option A? Option A, a transaction writes a data item. If I say T1 followed by T2, a transaction writes a data item after it is read by an uncommitted transaction, right? So if something is there, transaction T1 having the read operation and T2 is trying to perform write operation, but T1 is not committed yet. Then this is what kind of a problem? If suppose for example, if it is going to be committed, what kind of problem it might be? While discussing the concepts of concurrence problems, we discussed, right, various kind of problems. What is the meaning of Fountain problem? Here he got the one value of read operation. Here if you try to perform the read operation, you get the one more value, right? Fountain problem we call, right? Or else we can say that this kind of problem is also a kind of last update problem. But can we able to recover it? Yes, we can able to recover it, right? Because it is once it is going to be done commit operation. See, non-recoverable means what? We cannot able to get back to the old state, right? As it is done the commit operation, there is no problem for the recoverability, right? But if you take into the consideration of option D, a transaction reads a data item after it is written by uncommitted transaction. For example, if I take the T1 and T2, T1 is performing the written operation and T2 is performing the read operation, right? But here we haven't done any commit operation, right? Commit operation. Now, if something is going to be happen at this point of time, is it going to be rollback or not? Yes, it is going to be rollback, right? This kind of problem we discussed earlier. All kind of things we call it as dirty read problems, right? So meaning that if there is no dirty, so here the problem is a kind of a dirty read problem, right? If there is a dirty read problem, definitely it is going to be an irrecoverable state. Irrecoverable, right? But here there is a dirty read problem, I can say that is going to be irrecoverable state. If there is no dirty read, definitely your system is going to be in recoverable mode. Okay, fine. So take out the second one. Which level of locking provides the highest degree of concurrency in a relational database? Right? So you may not get the idea here. Basically, if I take the page, as per the yesterday's class, page means something like a collection of data, right? So trying to provide the restriction over the entire page, right? So if I say that page, on this entire page, if I am going to apply lock, right? Page means what? It's a collection of huge data. Huge data is going to access by many people, right? So when I am going to apply some kind of concurrency mechanism, if I am going to apply lock on this one, for example, exclusive lock on this one, only one person can able to access. It means that indirectly I am saying that on the entire database, I am going to make it apply lock. So at a time, only one person is going to access the data, right? So that's the reason it is not going to. What is the meaning of highest degree of concurrency? Maximum number of people can able to access the data, right? So I cannot able to get through this option, right? What about the table? Table means like if I say page is going to have collection of tables. Page is going to have collection of tables, right? If I am going to apply on table also, I am going to restrict on multiple rows or not. So it is also may not be the correct one. But if I take the row is the smallest unit in a database, right? So one row I am going to give it to one person. If I give it to another row to another person, then that will be the fine, right? But if I am going to give one row to multiple people, what will happen again? Again, it is going to violate the properties of atomicity, right? Simply as the example as like amount problem, right? In a particular row, account number, amount, right? If this particular row is going to be accessed by multiple people, then definitely it is going to lead to various kind of problems, right? So for this, the correct option is row mode. Right? So which level of locking provides the highest degree? Meaning that whatever the smallest unit that is available for us, on that you have to go for locking. That's it. Simple one. Right? Amongst next one, amongst the acid properties of transaction, the durability property requires that the changes made to the database by a successful transaction persist. Except in case of an operating system crash, except in case of disk crash, except in case of a power failure, always even if there is a failure of any kind. What is the option? What is the meaning of durability? Permanent, lifelong, right? So even if the power failure, even if any calamities happen, even if anything happened, our data should not lose. That's the meaning of durability, right? So simply option D is the correct answer, right? So in acid properties, what are the meaning of A? Atomicity, consistency, isolation, and durability, right? So durability means for any kind of a crash, our system should have to be capable of it. Should not lose the data. Isolation means if there is any data which is common for everyone, that should be accessed by only one particular person. Like mutual access should be guaranteed. And consistency means the database should have to be always in one consistent state to another consistent state. It should not be in the middle of the state, right? So if I am going to add plus 50, that should be 150 or 100, right? But should not be in between. Similarly, atomicity means we have to execute either all the lines of code, or you should not execute none of the lines of the code. I mean, if you are execute at the middle of the code, if there is any failure, you have to just go for the rollback. Or if there is no problem, you can just completely go for execution. That is what the property of atomicity. So for this, the best option is option D. Next one. Which of the following concurrency protocol ensures both conflict serializability and freedom from the deadlock? timestamp ordering protocol, right? So if you are able to understood the last classes, you can able to simply say that the answer is timestamp ordering protocol. So option B is the correct one. Why? If I say in timestamp ordering protocol, the order of the operands are going to be executed in timestamp order, as they are going to be executed in timestamp order, they are going to be definitely achieve the property of serializability, and it is going to be freedom from the deadlock. So the option is timestamp ordering. So, but if you take the conflict serializability, if you take the two-phase locking protocol, is it going to ensure only two-phase locking protocol is always going to ensure only serializability, but not the deadlock, right? So option B is the correct answer for this. Next one, for the schedule given below, which of the following is correct? The schedule is serializable and can occur in a schema of 2PL protocol. The schedule is serializable and cannot occur in 2PL. The schedule is not serializable and can occur in schema of 2PL. The schedule is not serializable and cannot occur in a schema of using 2PL protocol, right? So first, can you tell how can we say that the given transactions is going to be a serializable schedule or not serializable schedule? We can define it in three ways. One is result serializable, conflict serializable, another one is deserializable, right? So among the simple one is what? We can go with the some kind of graph based, right? Dependency graph if we are going to draw, then if it contains a loop, definitely is going to be a one not conflict serializable, right? So if it is not going to be satisfied, then you can go for serializability. So just try to draw the dependency graph between these two. If I say this is transaction T1 and transaction T2, T1 and T2, tell me what you are going to do. So what kind of conflicts you are going to draw the dependency graph? Read followed by write. So T1 to T2 definitely it is there. Read followed by write B. See, I am rightly writing few only. Right? Many of them are possible, but the possibilities I observed here are these two. So is it a loop? Yes. When it is a loop, definitely it is not going to be a conflict serializability. Meaning that as it is not conflict serializability, I can say that it is not going to be a kind of serializable property. If it is not going to satisfy at least one, I can say it is not serializable. So option A and B are going to be eliminated. So not serializable, not serializable. Among these two, which one is the correct one? Again, to accept the concepts what we discussed. Option D is the correct one. Why? Because if it has to be a 2PL, it has to be 2PL, definitely it has to be a serializable, right? As I am saying that it is not serializable, can we say that it is 2PL? No. So I can directly say that it is not occurring 2PL protocol directly. Next one. So I think you can do this one. Consider the three data items and the executable schedule of transactions. R of D and write of D denote the actions reading and writing the data items D respectively. The schedule is serializable as some of the options they have given, right? T2, T3, T1, T2, T1, T3, T3, T2, T1, and the schedule is not serializable. Which one is the correct one? So what we can do simply, we can able to find out the dependency graph. So if I try to draw the dependency graph, T1, T2, T3. So read of D3, any problem on the T1? No. Any problem on the T3? Yes. T1 to write of D3, right? So T2 to T3 there is a dependency, and R of D2 on the left side, write of D2, T2 to T1 there is a problem, and T2 to here it is all T3 also there, right, which is already there, and write of D2, T2 T3 already there, T2 to T1 already there, right? What about R of D2? T3 to T1, T3 to T1, it is there. R of D3, no. R of D1, yes. T1 to T2, T1 to T2, right? as it contains a loop, as it contains like I didn't complete all the things, as it contains a loop, I can say that the schedule is not serializable schedule, right? Next one, consider the following schedule S of transaction T1 and T2. So again they mentioned here they are serializable or not serializable, right? If they are serializable, on what order they are serializable, right? So for that what we can do, again we'll try to draw the graph T1 to T2, T1 to T2, read off here, read off here, read off here, write off here, T1 to T2, there is a dependency graph, right? And write off here, write off here, so T2 to T1, right? So I can directly say that the schedule is not serializable schedule, right? T1 to T2, as there exists a loop, definitely it is going to be a not serializable schedule. Next one, try to take the another one. I think this is 8. This will be the 9th one. Yes, consider the following schedule involving two transactions. Which one of the following statements is true? Right? If I take the S1 schedule and S2 schedule, is both are conflict serializable, or one is conflict, another one is not conflict? That is what they are asking. So how can I do this? Again, we are going to draw the graph, right? So instead of drawing the graph, if you have the option to draw there itself, what we can do now? We can start with the first one, read one of X, where might be the conflict occurring. There should be a transaction 2, right? So you have to check with the 2, right? R2, there is no problem. W2 of Y, no problem. And there are no other T2 transactions. So with respect to R1 of X, there is no problem for us. But what about R1 of Y? R1 of Y, if I start, R2 of Y, no problem, but W2 of Y, right? So there is a conflict. There is a conflict, right? Meaning that if I say T1 to T2, T1 to T2, there is a problem, right? And what about R2 of X? R2 of X, W1 of X. So T2 to T1, there will be a problem. So definitely S1 is not conflict serializable. What about S2? Read one of X, and in W2 anywhere write operation? No. So there is no problem. But if you take R2 of X, in T1 anywhere W1 of X? Yes. So T1, T2, so T2 followed by T1. And if I take R2 of Y, anywhere it is like W1 of Y? No. Good. And if you take W2 of Y, anywhere R1 of Y? Yes. So T2 to T1 already there. Now, so any other kind of dependency is there? No. So I can say that S2 is conflict serializable. So which one is the option? S1 is not conflict serializable and S2 is conflict serializable. Yes. So next one. So consider the following three schedules of transaction T1, T2, T3. Notation in the following: NYO represents the action Y. So they have just mentioned some kind of notation. Y represents, it can be read or write performed by transaction N on object O. What is the meaning of this one? If I am saying that 2RA, meaning that R2 of A, that's it. So they mentioned in a different manner to get the confusion, right? So R2RA is equal to R2 of A. Now they are saying that which of the following statements is true, right? So is all the three are conflict equivalent? That is first option. No two of S1, S2, S3 are conflict equivalent to each other. S2 is conflict equivalent to S2, S3, but not to S1. S1 is conflict equivalent to S2, but not to S3. So how can we do this one? Right? I said if you would like to find out whether they are conflict equivalent or not, what you have to do? So dependency graph is enough. Here conflict equivalence we are asking. We are not asking about conflict serializability. Conflict view equivalent is different. View serializability different. View conflict equivalent is different from conflict serializability. Right? Conflict equivalent means what? If I take the two schedules S1 and S2, both should have the same conflict operations. right? Yes. So you have to check with this one, right? It may take time. So can we check? So if I try to do, so try to define the conflict operations of S1. What might be the conflict operations of S1? So if I try to take the R2 of A, there should be write operation in 1 or in 3, right? So on the same item, right? If I say this one is a conflict, so definitely T2 to T3 there is a conflict, right? Similarly, here also there is, right? So basically you can draw the entire structure, right, to avoid the confusion, but when you practice you will get the idea, right? So here write one of it. So definitely one more kind of conflict, that is T2 to T1. Good. Next, this one, take this one, R2 of A, write 2 of A. So you have to have read operation or write operation on T1 and T3. Check this one. So this one, right? T2 to T3. Is it correct? Yes or no? T2 I am performing read operation, write operation on A. Similarly on T3 also I am performing the write operation on A. See how to go with the sequence, right? So T2 to T3 already there. And any other things are there? Good. So it will be T2 to T1, which is also already there. Any other things are there? Write 1 of A. So again T2 T1 is already there, right? Yes. Next, R3 of C. So you have to check with the write operation on 1 or 2. So write operation on 1 or 2 on C. No, right? Good. Next, write 2 of B. B మీద మనం ఏం చేయాలి? 1 or 3 you have to go with write or read, right? So write 2 of B anywhere. Read 1 of B unda. Yes. So that will be from again T2 to T1, again T2 to T1, right? It is already there. Conflict operations I am trying to write. Next, write 3 of A. On A there will be T3 to T1. Write operation on the same item A. So definitely there will be a T3 to T1. Any other things are there? Next, on C item. On C item, no, because no C observed. On A item, other transactions are not there. All are from T1 only. 1, 1, 1, 1. So no problem. Yeah, it's all 1 only. So there is no problem. So the conflict operations which you occurred in S1 are these 3, right? So if these 3 operations are occurred in S2, then I can say that S1 is equivalent to S2. Other than that, if you are going to get any extra, or if you are not going to get any like which is less than the conflict operations of S1, then I can say that S1 and S2 are not equivalent. So try to find out for S2. For S2, see, if I try to take the read operation on C, so C there is no problem, right? Because this C also on the same third transaction. What about read operation of A? Read operation of A, that A should be, right, this one. So T2 to T3, very good. And A operation on write 1 of A, good. So definitely T2 followed by T1, good. Next, similarly R2 of A, write 2 of A. When you take the write 2 of A, again T2 to T3, it is already there, we have written earlier. And if you take here write 1 of A, so read 1 of also there, right? So T2 to T1, it is already there, write 1 of A already there, and that's it. If we take here write of B, so definitely T2 to T1 we mentioned, 1 write of B, T2 to T1 we mentioned, And what about write of A? T3 to T1. See, if you observe here, if you observe these two, right? So with this I can say that T3 to T1 conflict is there, right? Next, T3 to T1 is there. That's it, right? What about the read one of A? Nothing. Read of B? All are from the same transaction. There is no problem, right? I think except C. But C is only one time, so there is no problem. So if you are able to observe, S1 and S2 having the same kind of conflict operation. So I can say that S1 and S2 are going to be conflict equivalent, right? So we can eliminate the option B directly. We can eliminate option C also, right? So you have to go with the third one also. If you check with the third one, you can definitely define the answer. So similarly, if you check this one, you will get the answer as S3 contains some other kind of conflict sum, but not equivalent to S1 and S2. So the answer will be option D, right? If you want, you can just cross check, right? So in other words, if I say, right, so instead of going like this, so for example, if I try to write T1, T2 and T3, T1 and T3, T3. So if I write the schedule S1, so tell me R2 of A, I think we need to write the again numbering, right? So read of A, write of A, read of C, write of B, write of A, up to here where? I think up to here we completed, right? So next, write of C, read of A, read of B, write of A, write of B, right? So if you are able to clearly observe, can we can we convert this kind of schedule into a kind of serializable schedule? Is there any chance to convert it into serializable schedule? We can convert, right? The reason is, if you try, so what is the meaning of serial schedule? You have to execute one transaction followed by another transaction followed by another transaction. If you are able to observe, already T1 is perfectly working on independent to other transactions, right? But if you look into T2 and T3, they are somewhat concurrent, right? But if you are able to observe, the concurrency is occurring between these two, but those two are also be independent, right? Those are also independent. So can I replace the same transaction like this? Can I interchange these two? Is there any problem? As they are independent, there is no problem, right? So I can write it as write of B and read of C. And read of C, right? Now I got the serializable schedule, right? Similarly, if you try to write for this also, for S2, if you try to write, for example, T1, T2 and T3, tell me R of C, right? R of C, R of A, write of A, write of B, write of here only, right? Write of A, read of A, read of B, write of A, write of B, write of C, right? Now if you are able to observe, can we convert it into again a kind of serial schedule? This one, can we convert? See, try to observe. I can convert it. The way is, if you try to, so anyway it is separate working, but it is interleaving only. If you try to observe, read of C, can I get back to at this point of time? Is there any, like T2 is going to be independent, right? Then T2 is going to be independent, right? So I can do this because it is working on data item C and these two are working on data item A and B. So there is no problem. So I can simply write the read of C to this point of time. So I can write here read of C, right? So now T2 is completely independent, it is going to execute first, right? Now if you try to observe write of C, write of C also I can get here, because even write of C is going to be executed at this point of time or executing at this point of time, there is no problem. But our point is here, I would like to get a serial schedule, so I can simply get to here. See, you can able to solve it in many ways. That's why I'm trying to take this one, right? So now this is a kind of equivalent schedule for this, right? So it is also, as you are going to get both are going to be kind of serial schedules, I can say that these two are conflict equivalent again. But if we try to draw the structure for this one, T1, T2 and T3, read of A, read of C, write of A, write of A, right, write of B, write of C, read of A, read of B, and so on, right? Anyway, T1 is completely independent, but how can we get back T2 and T3 into a serial fashion? Is there any possibility? Just check. It is not possible to get into serial schedule, because if you are able to observe the conflict operation, right? If I execute the write operation of T2 first, then T3, there is a chance of getting misleading, right? So it is a kind of our common sense. So I cannot able to get back our actual data. So that's the reason S3 is completely different from S1, S2. So I can say S1 is conflict equivalent to S2, but not to S3. Right? Just try to read the question. Consider the following two transactions T1 and T2. So T1 they have given as read of A, read of B, and write of B. T2 they have given as read of B, read of A, and write of A. Which are the following schemes using shared and exclusive locks satisfy the requirements for strict two-phase locking for the above transactions? Right? Means that they are asking for which are the following schema when we are going to apply locking mechanism will lead to strict two-phase locking. Right? What is the meaning of strict two-phase locking? You have to have unlock a data item. First, it has to commit it, right? It has to commit it, right? So, and what is the meaning of 2PL? You have two phases. One is growing phase first, then followed by shrinking phase, right? So, based on that, first we can eliminate the options. So, if you are able to observe the first one, S1, I think all are going to be lock, then all are going to be unlock. S2, all are going to be lock, and all are going to be unlock. So, with that point, we cannot able to eliminate. What about S1 and S2 of option B? Lock, and then unlock. So I think they haven't given with respect to this option elimination. Lock followed by unlock, lock followed by unlock. Option D also lock followed by unlock only. So we cannot able to simply eliminate with that particular option, right? So what might be the other option? You have to go with unlock of a data item, but it has to be commit before it, right? So if you are able to observe, or else first try to go with the first S1. If you go with the S1, lock of S of A, lock of S of B, write of B. I think this option directly eliminate. Why you can eliminate? If it wants to be a 2PL, if I am trying to perform some write operation, what it has to do? It has to have shared lock or exclusive lock? Exclusive lock, right? So option A is directly eliminate, right? Because write of B requires exclusive lock, but here only shared lock is there. So option A is eliminated. What about option B? Option B, if you are able to observe here, write of B, here, like my point you can observe, write of B, unlock of B. But as I performed a write operation, unlock of B requires what? Commit operation. But is there any commit for write of B? Yes, right? Unlock A requires commit. That is rigorous 2PL, right? In strict 2PL, we are going to consider only write operation, right? Write of B, we require unlock of B for commit operation. Yes, done. There is no problem. What about here, this particular side? Write of A, unlock of A, commit, unlock of A. Okay, so is there any problem in this particular S2 option? Any problem is there in S2? We have to unlock the B, right? At the end, we have to unlock the B. So option B you can eliminate with respect to this one. We have applied exclusive lock on B, but we haven't performed unlock of B. So option B eliminated. What about option C? So before option C, go with option D. In option D, can we able to delete the option? Delete this option. In what sense? Unlock of B, first one. In S1, unlock of B requires what? Commit, as it is performing write operation. So option D also eliminated. So the leftover one is option C. Right? If you check the option C, definitely is following all the runs. Write of B, unlock of B, commit. Write of A, unlock of A, commit. Unlock of B done. And as I am not performing write of B, there is no required of commit operation. Right? So option C is the correct option for this one. So option C is the correct one. Next one. Consider two transactions T1 and T2 and four schedules S1, S2, S3, S4 of T1 and T2 as given below. Which of the above schedules are conflict serializable? Right? Can we able to do this by your own? Right? So what you have to do simply, you can just check with the dependency graph. If there is any loop, it is not conflictable. If there is a no loop, then it definitely is going to be a conflict serializable, right? So you can just check with this one. So I think for this, option B is the correct one. Let us do why option B is the correct one, right? You can eliminate the remaining things with your practice, right? So if you go with S2 and S3, S2 R1 of X, is there any write 2 of X? No write 2 of X, right? There is no problem. Next, R2 of X, is there any write 1 of X? Yes. So there is a graph between T2 to T1. Good. Then R2 of Y, write 1 of Y. There is a T2 to T1 and T2 to T1. Good. Write 1 of X, no problem. Write 2 of Y, write 1 of Y. T2 to T1 only. Is there any loop we got? No. So I can say that S2 is conflict serializable. What about S3? S3. Read 1 of X. And is there any problem with W2 of Y? W2 of X? No. W1 of X with R2 of X. So T1 to T2 is there. Good. Next, R2 of X, nothing problem. W1 of Y, R2 of Y. So again T1 to T2 only. W1 of Y, W2 of Y. Again T2 to T1 only. Again there is no problem with this one. So there is no loop. I can say that S3 also conflict serializable. So option B is the correct answer. Right? You can able to eliminate the remaining all. Right? Okay. Next, do the next one. Consider the following schedule of transactions T1, T2 and T3. Which one of the following schedules below is the correct serialization of the above? Right? If you take the operations here, what you have to check here? First, yeah, you can. So I think in the classes I have explained, right, how to draw this is topological sort, right? So topological sort you are going to draw by drawing the dependency graph, right? So if I take T1, T2 and T3, so read of X, T3, are you going to get? Yes. Read of X, write of X. So T1 to T2 definitely there, T1 to T3 definitely there. Similarly, read of Y for T3 no problem, but for T1 also no problem. Write of Y, This read of 5 you have to consider, right? T3 to T1 you have the problem. T3 to T2, T3 to T2, very good, right? So as I am going fast, I may made mistake. You can just rectify. T3 to T2 done. Write of y there is no problem because there are no other write operations. Write of x T1 to T2 it is already there. T1 to T3 it is already there. This write of x T3 to T2 already there. T3 to T2 already there, and no further transactions are there. There is no problem. So this is my final graph you are going to get, right? So with this, what is the first one you can able to execute directly? T1. If you remove the T1, so directly option A is the correct answer because all are going to start with the remaining things, right? So directly if you remove the T1, the next executable one is T3, next executable one is T2. So T3, T1, T3, T2 is the correct sequence. So topological sort you have to do. Next one, I think 13th one. This might be the 14th one. Right? So try to observe. Consider the following transactions with data items. Just read this one. What might be the answer? So here they are asking for consider the following any non-serial interleaving of T1 and T2 for concurrent execution leads to. For concurrent execution leads to a serializable schedule, a schedule that is not conflict serializable, a conflict serializable schedule, a schedule for which a precedence graph cannot be drawn. What we can do? It's a kind of again new thing, right? Looking like a new one. Just check. So what we can do based on the options you can go, right? Based on the option, right? First, if I would like to say whether it is conflict serializable or not, what you can do simply, you can go with the drawing the dependency graph, right? So just go with the drawing the dependency graph. So if I try to write R of P, this is R of Q, this will be the right of Q. What about the interleaving of X, like these statements, is there any problem? We are always going to check with only read and write operations, right? So if you try to say this one also, read of Q, read of P, write of P, right? If I try to say, if I try to draw the graph for this, according to the option, can we able to make this schedule as non-conflict serializable? Is there any chance? See, I am trying to write. So if I try to take the T1 followed by T2, no, na. See, they have given the only like some kind of serial schedule actually, and they are saying that it is serializable schedule. If you would like to say that it is serializable schedule, it should be conflict equivalent or conflict serializable, or they are saying that it is not conflict serializable. So based on the options you have to go, right? If I would like to say that it is serializable schedule, it has to satisfy for all cases. And I can prove this one, or I can prove this one, or I cannot able to draw the dependency graph this one, right? If I take the T1, T2, R of P, R of Q, right of Q, R of Q, R of P, right of P, right? Basically, this is what they have given, and they are asking for is it a serializable schedule or not? What is the meaning of this one? Can we able to construct any kind of conflict serializable, or can we able to construct any kind of view serializable, or can we able to construct any kind of result serializable or not? That is what they are saying, right? So if I am going to prove that if at least one serializability is not following, I can say that it is not serializable schedule, right? So for that reason, what I can do, I will try to execute these transactions in an interlude fashion. If I try to execute read of P, read of Q, read of Q, and read of P, right of Q, right of P. Is it one kind of conflict, like kind of interleaved execution or not? Yes, right. Can you able to draw the dependency graph for this? If I draw the dependency graph, what will happen? I think here there is a kind of conflict. Read of Q and read of Q and write of Q. Right? So definitely there might be T2 to T1, there is a kind of a conflict. And if you are able to observe read of P to write of P, T1 to T2, there is a kind of conflict. As there is just a kind of conflict, I can say it is not conflict serializable. As it is not conflict serializable, I can directly eliminate option A. Directly eliminate option A. What about option C? I can eliminate. What about option D? Can we able to draw the dependency graph for it or not? See, whatever the order it may be, definitely we are going to draw the dependency graph, right? So option D also eliminated. So final option is option D. It is a kind of a simple schedule. It is not going to be a kind of conflict serial. So sometimes you have to go with the reverse order also, right? So based on the way you are trying to understand the question, it will be you can able to easily solve it. Okay, right. I think this is the latest question. What I have posted in the group, GATE second phase group, right? Early morning posted somebody, right? So I think it is not clear for you. So if I try to write, so this will be the, I think remainder are understood, read of x ma, and this is going to be write of x and followed by commit operation. This is going to be a write of x after this ma, and this will be the commit operation. This is write of y, and this will be the read of j followed by commit. I hope you understood now, right? This is read of x, read of y followed by commit. I think it is correct, right? Okay na? Where is that question? Read of x, write of x, commit, write of x, commit, read of y, read of z, commit, read of x, read of y, and commit. Yes. So it is correct. Now try to define which one of the following statements is correct. Is S is conflict serializable but not recoverable? Not, so they are asking here, pointing out with respect to conflict serializable and recoverable, right? So can we able to simply find out the conflict serializable or not, right? So we can simply draw the dependency graph. So if we try to draw the dependency graph for it, T1, T2, T3, T4, right? So try to define any conflicts are there. T2 to T3 there is a conflict. T2 to T3 there is a conflict. T2 to T1 there is a conflict. Good. And any conflicts are there with respect to T2 of the R of x? No. W of x, T3 to T1. Right, T3 to T1, yes, it is there. T3 to T4, it is there. Right? T3 to T2, no problem. T3 to T2, no problem. What about this one? T1, right of x followed by T1 to T4, right? T1 to T4, that's it. What about right of y? T2 to T4. T2 to T4, Z no problem, and this is no problem, right? Finally, is it contains a loop? I think there is no loop, right? As it is not having any loop, I can say that definitely it is going to be a conflict serial. So option B, and so I think not conflict serial option is only one, right? So I can neither conflict serializable nor it is recoverable. So option D I can eliminate. Okay now. What about the recoverability? What is the meaning of recoverability? In the first question itself I have explained, right? you have to check with the dirty read problem. If there is if there is no dirty read, first of all, if there is no dirty read, definitely it is going to be a recoverable schedule. It is going to be a recoverable schedule. Am I right? If there is a dirty read, when it is going to be recoverable? When there is commit operation precedes the read operation, then it is going to be recoverable. Try to observe, is there any kind of dirty read problems are there? Yes, sir. Write followed by read. Yes, there is dirty read problems are there. If you try to observe T3, T4, write followed by read operation, definitely dirty read is there. But this precedes what? Commit. When it is going to be commit, definitely there is no, definitely is going to be recoverable schedule. Right? Yes, it is going to be recoverable with respect to this one. What about any other operations of write read operation? T1 to T4 also. Here write operation, here commit done. So there is no problem. In other things, here T2 to T4. Yes, write of I, here commit done. After this commit only read of I done. So there is no problem. So even there is a dirty read, it has following the commit operation. So I can say that it is going to be a recoverable schedule. So it is going to be a conflict serializable and it is going to be a recoverable. So option C is the correct one. Right? Fine, right? So I think these are the questions that I have gathered. I hope you got clarity, right? So regarding the concepts of all the things. So any doubts are there? Right? Let us take one more question. If I try to observe the write 1 of x, write 2 of x, write 3 of x, read 2 of x, write 4 of x. If I say the statement S1, if I say the statement S1, the given schedule is possible under timestamp ordering protocol. Timestamp ordering protocol. This is also one of the gate question. And I am taking the statement S2. The given schedule is possible under Thomas Wright rule. The given schedule is possible under Thomas Wright rule. Right? Can you tell which one is the is S1 and S2 are correct, or neither S1 or S2 are not correct? Like that, they have given the options. So if I take the T1 followed by T2, so try to write down, right? So it is easy one compared to, right? So in timestamp ordering protocol, what they are trying to say, the order in which they are going to be occurred, in the same order you have to execute, right? In the same order if you are going to execute, if there is any older transaction is going to be happen with conflict operation, then definitely is going to be a not timestamp based protocol, right? Try to note down, write of x, write 2 of x. If I say T3, write of x. If I say T4 is there, after write 3 of x, there is a read 2 of x. Read 2 of x, then write of x. Now with this example, can you understood? Is it a timestamp ordering protocol? Yes, sir. No, because here R2 happen at what? For example, if I say this is 10 o'clock, 20, 30 units of time, 40 units of time, right? And here, if you are able to observe, there is a conflict. When there is a conflict, it has to be executed before T3 itself, right? Meaning that the order of the transaction should be executed in ascending order. So as it is trying to execute T3 after T3, then I can say it is not timestamp ordering protocol, right? At the time, what you can do? What is the solution? You can just roll back this entire transaction T2 and you can come up with a new timestamp ordering, right? So then order of execution will be T1, T3, T4, T2. This might be one more kind of possibility of the question, right, to overcome this problem, right? So option S1 is not true. What they are saying? They are following timestamp ordering protocol or not? Timestamp ordering protocol they are saying. Coming to S2, is it a Thomas Wright rule? Is the schedule, the given schedule is like the given set of transactions is following Thomas Wright rule? Again, it is no. Why it is no? Right? Thomas Wright rule is saying simply that when there are any kind of right follow to right conflicts, you can just simply ignore. That's it, right? But they are not thinking about, they are not defining specifically about right follow to read operations, right? So it is not going to come under Thomas Wright also. So both option S1 and S2 are false, right? So if you want to make it correct, so it has to be executed T1, T3, T4, and I can come up with another kind of new timestamp ordering, new timestamp. So this is going to be write of x, write of x, write of x, write of x, and followed by right. So with this we complete our 16th item. Okay. So if you have any doubts, you can ask. Otherwise, we can wind up the class.